All right. Okay, everyone. Happy Friday. What a short week, huh? Yes. All right. So we'll pick up where we left off. Usually I have recap questions for you at the beginning of every lecture, but we haven't gone so far. We only started talking about couple slides. So just to bring us where we were just talking about food composition. Can you quickly tell me what food composition means to you? When I say food composition, what are we analyzing? And say your name first. Razzie.
Yep. It's like the chemical composition of the foods, like all foods that make it up.
Chemical composition. Can you give me an example? One example. Anybody? Go ahead, say your name.
Means gray, protein.
Protein. Gets +3 for that? No. Okay, so chemical composition, anything that makes up the food from macronutrients to micronutrients, and we analyze them to understand quality, nutritional benefits, stability over time, and a lot of that will be covered in so many different chapters later on. Oh, okay, so we're not doing nutrition labeling. Hold on a second. We are not yet done with the introduction. Just projected the wrong slide. Okay. And we talked about why we analyze that for different reasons, including we're looking for low fat as a consumer, or we're looking for more calcium in our diet, or we need to follow regulation for standard of identity. Nutrition benefit, quality, all of that sort. So this will be the subject of almost the entirety of the semester. Okay, so if we are food analysts, if you work in a lab and in a company and you're a food analyst, or if you are a graduate student and you need to do some analysis, you want to think about why do I need to do analysis or determine composition or determine other characteristics of food? Why do we do that from a consumer perspective? Think as a consumer. Why would we analyze food? Why do you care? Go ahead. Say your name.
Sophie, to make sure that what is being given to consumers meets their expectations.
Very good. So we have expectations, whether it is health expectation or whether it is a quality expectation. So consumers have expectations that we need to cater to. Quality. Very good. Safety is another. So, of course, we talked about safety. Safety can be microbial safety. We don't cover in this class, but still analysis. It could be chemical safety, like components that shouldn't be in the food, chemical components like pesticides, for example, or physical components like glass or metal that shouldn't be in the food. Okay, so another one is nutrition and health. So high protein, low fat, low sodium, or let's say high fiber, calcium, like I mentioned. So if we're having certain consumer interests in certain health components, then we analyze food to put a claim on the label to tell the consumer, hey, this is high in calcium or a good source of iron. Or, for example, it's gluten-free because if you have gluten sensitivity, you don't want to have gluten in the food you're consuming. Okay. So, health claim, let's think about which of these components we measure for a health claim. Saturated fat, phytochemicals, free fatty acids, all of the above. Tina.
Obviously, saturated fat because I intake of the saturated fat will cause and the common heart disease.
Absolutely. So saturated fat is a component that we care about because of its relation to a coronary, to heart disease or cardiovascular disease. Anything else on this list that you would think we need to analyze for health claim? Go ahead. I know your name. Let me guess your name. You. Starts with a U. Okay. You got it? Alright. I don't have, I wanted to cheat, but I gave them the list. I don't know. Okay, go ahead. You forgot?
There's 356, so then.
From here, from these
Yeah,
three options, is there anything other than saturated fat we care for a health claim?
yeah, 356, then we have like 356, so.
Free fatty acids, okay.
Yeah, so it can cause like, heart diseases.
Free fatty acids cause, hold that thought. Hold that thought. Who would want to comment on free fatty acids and the importance of measuring free fatty acid? Is it from a health perspective or something else we care about?
Well, the content of free fatty acids correlates to the full intake, intact triglyceride breaking down and the grease broken down, and the more free fatty acids there are, the more chances for oxidation, oxidation, and those things could be related to coronary heart disease and cause problems, but not as strong.
Okay, so you're both right and you're both wrong. All right, so it's okay to be wrong. I'm wrong many times. So what you said is correct about the relationship of free fatty acid to oxidation to bad consequence on health. But here, health claim. Of course, you're not going to put a negative claim on your product, right? So here, when you think about health claim, you're putting something encouraging for the consumer to buy the product. So it's not the health concern. What we both talked about is health concern.
For phytochemicals,
Yeah.
for sure, you can say things
Yeah.
like beta-glucan.
Yes, absolutely, and the relation to health. So when we say health claim, we're thinking positive. When we look at fatty acid, high fatty acid content, it's an indication of hydrolytic acidity, shelf life. It's an indication that there is high chance of oxidation, shelf life, and potential adverse effect on health. Okay, so you're both right in that sense, but for health claim, it wasn't related. All right, so what is the correct answer is A and B, just in case you want to write that down. Okay. So we talked from a consumer perspective. Now from an industry perspective, why, every food industry company, they do analysis. Why? Anything you can think of. Go ahead, say it.
Gram,
Yeah,
quality.
quality, consistent quality. So because the consumer cares about quality, the company cares about providing that quality and consistency. So every production needs to be as consistent to the previous one as possible, because every time you buy a product, if it tastes different or has different component, then the consumer is not going to be happy, because why did it change from the last time they bought? So, and also meeting, producing new yeah, go ahead.
Yeah, we do like substitutes.
Yeah.
They're like favorite time, they have to not substitute.
Exactly, yes. So product development and substitution of ingredient. Absolutely, that is correct. It's right there coming. Anything else you can think of? Yes, go ahead, say your name.
Jordan,
Jordan.
I like for companies there, but they also want to be as most cost effective as possible.
Yes, absolutely. Sometimes they switch ingredients and they want to reduce their cost, but at the same time, they want to maintain shelf life stability. They want to maintain total certain macronutrients, micronutrients. So once they shift and change ingredients to reduce costs, they want to maintain the quality. So product development. So basically consumers, they're always asking for new foods and new varieties. So once they develop new products, they need to analyze those new products from what can we put as health claims? What can we put on the nutrition label? What is the shelf life of this new product? And so on. New processes, and I'll give you an example. Oftentimes, an equipment dies out or they need a more efficient equipment. The use of a new equipment might shift the quality and they need to adjust, let's say, temperature time combination or hold time might be a little different. So that might impact the quality and the consistency of the quality. And I'll give you an example in a little bit. And the cost that you mentioned, that also is always a thing, always the company looking to reduce cost. Solve problems. We call it food forensics. And I'll give you an example about that. Sometimes, you know, in industry, you have the suppliers, you have the producers, and the producers are the customers for the ingredient suppliers. And then if something goes wrong, they go to the ingredient supplier and blame them. You gave us something off. So, and then the ingredient suppliers start to investigate to see is it their own ingredient or the process of a CPG company or producer. So we'll give you an example about that. And compete. Boy, isn't that a big thing in industry. So have you ever been to Target, for example, and you have the up and up? So it's almost a copy and paste of different products. So they need to analyze the competitor product and try to produce something similar to it. So competition is always a big thing. Government regulations, like we said, we need to make sure that we meet the requirement if we have a standard of identity, or if we need to do a nutrition label, we need to meet the government requirement of the tests and type of tests we do to produce that nutrition label. And I'll give examples throughout as we go. All right, let's start thinking about some of these questions together. So this is for a product development example. So you're a food scientist in R&D, research and development. You were asked by the management to replace butter with vegetable fat in order to reduce cost. What food analysis tests will be involved in this process? Think anything, not only chemistry, anything you can think of. When you're asked to remove butter and put vegetable oil, what would you start thinking? What would race in your mind, Kendall? Okay, so that's the characteristic. So what's going to happen to my product? Go ahead and say it. Yeah, water content. Yes. Okay. So what's the percentage of water in butter? You know? Or is there water in butter? You know, 20% is on average. Do you think there is water in vegetable fat? In margarine? It could be, depending on how it gets produced. So moisture it could be something that they will look at, but what else?
Flavors and colors. Those
Flavor, color, so that would go with sensory and physical properties. Very good. What else? What? Go ahead and say. Absolutely. Saturated fat content, cholesterol. Well, there is no cholesterol in vegetable oil. But now that you are talking about saturated, what other than saturated you might be looking at? The opposite of saturated? Unsaturated or unsaturated, how would that impact what is it impact?
Oh, unsaturated fats, it health claims. You can also, there's also the chain link of the triglycerides that's really popular right now too.
What else would be impacted if you have high level of unsaturation?
Shelf life.
Shelf life. Shelf life, stability, flavor, acidity over time. So a lot of things that you start thinking about is you think what you listed, if I summarize from a textural perspective, from a flavor perspective, from a color, physical perspective, now from reactivity perspective and stability. So there's so many different things that you start thinking about when you're just changing one ingredient. So yeah, good. New processes. This is something that comes from real world experience. About, I don't know, 8-9 years ago, I went on a sabbatic. I worked at Cargill. I worked in the developing the protein team, and they had this problem happen. So they produce soy flour and they actually sell it for a company that uses it for fermentation purposes. So protein content is very important for the growth of that microorganism. Now, as you know, that soy needs to be treated to inhibit some enzymes and anti-nutrients. So when they're producing that soy flour, it goes into a cooker and it gets treated to meet a certain requirement, and then it goes to the customer. Now, they wanted to replace the cooker. And then when they replaced the cooker, they kept the same conditions, and then the flour went to the customer. The customer said we had a decrease in growth of that microbe. So as we're, analysts at Cargill, what would you do at this? What would you look for? So what happened? The growth went down. So where would your mind go? Go ahead and say your name. Graham, sorry, Graham. If you can watch your comment a little bit. Huh? That's good. Okay, so moisture is really important for like the physical characteristics and stability of the flour. But if you're thinking about the growth of microorganisms, okay. Yeah, okay. I see where you're going with that. That's a good point. But I wasn't looking at that. The key, there is a hint in there.
They're actually reaching, like, protected the.
And then what is that temperature impact? What component? It's right there. Protein. Yeah, so what happens to the protein? So it could have denatured, it could have polymerized. Then if it is denatured and it found a big polymer, then it won't be digested as readily by this microorganism. Yeah, you want to say something?
Could it also be that the new cooker wasn't effective or thorough enough that the antimicrobials in soy flour were allowed to persist?
Perfect. So that's a good point brought up, is what if there is an issue with the cooker? And it's absolutely right, because we designed an experiment where we looked at different time temperature combinations to get us to where we were. So we designed those different experiments and different tests that went around the anti-nutrients and the protein quality to kind of nail down what conditions now with the new cooker we need to get to where we get. Okay.
Question,
Yes, good.
did that change the amount of soy flour they were putting through per day?
Not
The throughput?
the throughput of the soy flour, it's for the cooker?
Yeah.
I would go back and ask, but I don't know. Yeah. Well, definitely if you want to put it longer through the equipment, yes, that will impact that. But I don't remember what was the outcome in that particular case. Here's another example where a customer complained. So you're the ingredient supplier, and then the company that buys your ingredient came back to you with a complaint. So here it is. So you're selling a pellet, a cereal-based pellet, to various customers. They process the pellet, which I don't have here, I should add. They deep fry it, and then they package it. So there is oil involved. Every year I say I should add that, and then I forget. Well, I did put fried. Okay, so I forgot that I updated it. All right, so it's right. Saj, don't laugh at me. Okay. When you're my age, then we'll see who's laughing.
Forget to remember, forget,
What's that?
forget to remember, forget.
Yes, exactly. All right, so the customer complained that the finished product was rancid. Okay. And then they said, it's your fault. The palette that you gave us was rancid. Okay, so what you do is, okay, you have loyalty to your company, so you want to investigate. So you obtain packages of the product from the customer. What might be the reasons of the problem, and how would you go about figuring out what the problem is? All right, let's go with your name. Samini, yes, okay.
Is it possibly like the oxidation, like it's going to be oxygen?
Yes, so you want to measure oxidation, or the measure, correct. What else? How would you go about it? Go ahead. Look at the packaging. What do you want to look at the packaging? So problems with packaging, is it permeable to oxygen? Is there any holes in it that allowing oxygen to go in and cause liquid oxidation? Very good. What else? I saw some hands up. And then, yeah, and then, Emma.
Maybe that region of awareness and so forth, and this house of man, so it was a access to
Very good. The oil, so you get the oil sample. Hold that thought. What did you?
Can't light lead to oxidation, so that's a seafood package.
Absolutely. So what is that package doing, whether it's permeability to oxygen or whether it's light? Storage. How are they storing their packages? So you have this responsibility and duty to investigate. You become the detective. You collect samples, you get a packaging sample, you get the oil sample, you take your initial ingredient and the final product, and you look for oxidation products. And then determine it's the package fault, permeable to light, to oxygen, it's the oil, it is actually our fault, our palette, or it is how they stored the palette or how they stored the sample after packaging. So many things, variables that you would be looking at. Food forensics. This is cool one, and this is a true story as well. You are a researcher in an ingredient company. Actually, all of them are true stories. One of your customers sends you a product formulated with one of your ingredients and tells you there is a sharp foreign matter in this product. What would be your approach to identify the foreign matter?
The hassle now.
So you look at the HACCP, yeah. But if you say you have a product in your hand, how would you determine if there is foreign matter and what that was? Go ahead. Say your name first. Yeah. So she's close. You use, well, if there is a metal, a magnet, but if it is sharp like glass, you want to look at it with a spectacle, well, microscopy. And there are different types of microscopies that might be available to you at your company. And actually, they did look at, they did SEM. SEM, it is scanning electron microscopy in that case, and they determined actually that was a crystallized sugar. It wasn't glass. Yeah, so it was a very interesting case. Compete. And boy, do we compete in companies or in industry. It's a big deal. Next week, you're going to learn a program called Tech Wizard, and you're going to generate nutrition label, and you're going to do reverse engineering. And well, I answered the question, okay? Well, the first thing you do is you take the package or the product of a different company, you look at the ingredient list and you look at the nutrition label, and you're in the program, like the program you're going to use next week. And the first thing you want to do is figure out their formulation or approximate formulation. Of course, the package doesn't tell you they put 100 grams of sugar plus 20 grams of vegetable oil. It doesn't tell you. But you have the nutrition label and you have the list of ingredients, and you try to estimate using the program the formulation. And that would be the first thing you would do before you go into the lab and do actual chemistry. And that's one of the things you would do next week, which is really cool. The Tech Wizard program is actually really a very well-used program. Different companies have different programs, but it's good exposure to see how nutrition labels are formulated, and then how you can reverse engineer to determine the formulation of a product. Okay, any questions about all of that? So far, we're just going over introductions. Throughout the semester, everything will fall into place in terms of, different types of analyses, different products, and what kind of analysis we do for each type of product. All right, so we talked about from a consumer perspective why we analyze food, and then we talked from a producer perspective why we analyze food. From a government perspective, why do we analyze food? Why do we care? Why does the government care? Go ahead.
They can trace it there. So like, something goes wrong, trace it back, see it went wrong.
Yeah, blame someone, put them in prison.
Well, along those lines, no one but the government has the capacity to indict or sue an item of food.
So the government has, well,
And if
along
they're
those
doing-
lines,
They need the capacity to make sure they're doing it.
do you know the body that governs food? What is it called? FDA, the Food and Drug Administration of the USDA, of the US Department of Agriculture. So they have the obligation to ensure food is safe. And if you want to trade as well, external, like the import and export, it has to follow through the procedures and ensure certain quality before a food can be imported or exported. So the government regulates these things. The government regulates nutrition labeling as well. So the government kind of makes sure that everybody's following the rule and the customer or the consumer is protected. So the government governs nutrition label. We'll talk a lot about that. So what goes on the nutrition label it has rules, what goes on and what shouldn't be on the label, and how do we analyze those different components. We should use something we call official methods of analysis. These are approved by government bodies. Good manufacturing practices, of course, you're taking food quality or you have taken it already. So good manufacturing practices ensure safety and also sanitation, cleanliness. And then there's the hazard analysis control, critical control points, where you look at the process and you make sure that within your process, you take care of potential hazards. And then Code of Federal Regulation. It's kind of like the Bible of the food kind of thing. That's where you find regulation for standard of identity, regulations for labeling, regulations for methods of choice. And then a codex, this is the entity that controls export and import of food. So, and then all of this, if you want to read more about, it's in chapter 2, which I don't cover in particular in this class because food quality covers a lot of that. So, management of product quality to ensure safety of the consumer, the well-being of everybody involved in the production of food. So we used to have a project in this class, and I did mention this briefly last time. In that project, each student would pick a product, and it would be a paper exercise where you list the ingredients that go into this product, the processing sheet diagram of that goes through to produce the product, and then your final product. And at each stage, you determine how you sample, how you analyze, how you decide on the data. And it just shows you the whole process, because at every stage, analysis needs to be done. So when you are a company that gets raw material, you have to have the following. You get the product or the ingredients with a specification sheet. And on that sheet you get from your supplier, it says certain things like if it's milk, what's the microbial count, or what's the somatic cell count, or what's the total moisture content. So you get a specification sheet, and sometimes you have your select suppliers that you have trusted over years, that you don't have to always, every time you get a shipment, you have to analyze what they gave you and make sure that they gave you the correct ingredient. So you have your own select suppliers. The suppliers often give you a certificate of analysis. So they certify that this product has no pathogen in it, or they certify that this maximum salt content is whatever. So they give you this certificate of analysis. They have done the analysis, they give you the data, and they certify the correctness of that data. And sometimes you do your own testing. So you want to ensure that, let's say you're getting milk from first-time supplier, you want to ensure that the water content is no more than 87%. Because if you have water more than 87%, that means what? What would it mean to the milk? Washed down, adulterated, they added water to it. So you do your own in-house testing to ensure the starting material quality. And then during processing, you do checks during the processing. So, okay, what did the pH drop to? You are producing yogurt, so the pH has to drop to a certain level. What's the moisture content? Because you have heating. So how are you impacting the moisture content? Are you causing sugar crystallization? Are you denaturing the protein during the process? So whatever is your process, you ensure the properness of the process by doing check or control samples taken out and analyzed. Final product. So you do whatever you need to do based on the product to ensure consistent quality. And then whatever you need to analyze to generate the nutrition label. And that's when the government can come and audit. They can look at your product, look at the nutrition label, and then come to your company at any time, pull samples and analyze. If they are not compliant with what you say on the label, then you go into legal issues. And whether the product is acceptable, oftentimes they do quick sensory testing, sometimes they do more elaborate sensory testing, and then whatever analysis if you're trying to put a health claim on your product. So as we go through the semester and you learn a lot about the different analyses and examples of different products, this will become really makes more sense to you. And that's why the project that was part of this class used to be kind of end of the semester. You work on it the entire semester, and then everything comes together. But lucky you don't have to do it anymore. Do you want it? You want the project? Not really? It's okay.
I think it's own. Yeah.
Ah. All right. Well, there's an example project online on Canvas under week 1, in case you're curious to see what those poor students had to do. Okay. So as food analysts, what do we need to know before we embark on this analysis journey? There's a lot of things we're going to learn throughout the semester. Do you think we have one method for moisture analysis that everybody uses? No. We have like 20 different methods for moisture. Same with fat, same with protein, same. It's like the sky is the limit. Creativity of food analysts over the years created so many different methods. So as a food analyst, first of all, you want to know what do you want to analyze? What is the food that you have and what do you want to analyze? So what's the case? What's the situation? Examples we gave you. Changed the fat type. Okay, so now I need to look at oxidation or unsaturated fatty acids. So now I know what I want to analyze. So that's the first thing. You need to know what your objectives are and what you need to analyze first. Second, okay, you have a plethora of methods out there. Which method I should use? Okay, there are a lot of factors that goes into deciding which method, and I'll talk about it in a minute. Actually, a lot of the chapters in your book talks about the different characteristics and the 100 different types of methods that are out there for you. Then you need to select a sample. That's chapter 5 in your textbook. So how do I select a sample out of the entire lot? If I am producing 100 tons, or if I'm producing 1,000 cans of tomato soup each day, do I need to analyze all of them? Do you usually analyze all of them? No, Bradley. You'll never go home for like 100 years.
Worth it.
I love the energy. Okay, but no, you don't have to analyze the entire lot of production. You would have to take a representative sample. So in chapter 5, we will learn about that. And also, how do we prepare the sample for analysis to avoid errors? So this is more important than the actual method of analysis, because if you prepare the sample wrong, you're guaranteed you're going to have wrong answers. Also, if you don't take representative sample, you're guaranteed you're going to have a wrong decision and make your company lose money. So this chapter 5, although it's very boring, heads up, it's coming, very boring, but it's very essential. So you got to bear with me. Analytical techniques. So we're going to learn about chromatography. We can use it almost in everything. We're going to learn about spectroscopy almost in everything as well. You do absorption and fluorescence and other sorts. We're going to learn about mass spectrometry. We're going to learn about immunoassays. You're going to learn about so many different techniques and how we apply them. And then you analyze the data. So once you collect your data, we're going to learn about how do we summarize the data, how do we report the data. And this is chapter 4. I'm going to talk about that. And then you're going to make a decision based on your data. So what do I do? Throw away the lot or go ahead with it? What's the risk to the consumer? What's the risk to the producer? So we're going to talk about all of that as well. And in each step, you want to mind government regulation, choice of method, process, labeling, making the decision, all of that. Okay. So let's look at this question. Type of analysis to be carried out is determined based on type of analysis. So basically, what do you want to analyze? Type of the product, health claim, or purpose? Tina.
Type of the product and the purpose, like what are you going to?
Okay, these are both correct. Go ahead. All of the above. So health claims. So if you are doing an analysis to see if you can say it's a good source of calcium, you'll see that for whatever type of claim you make, you need to have a specific amount and content within your serving to make a claim. So if that is part of the purpose of your analysis is the health claim, then yes, you would take into consideration to determine the type of analysis you do. Okay, so all of the above. And this is recap. We'll keep it for next time. Then, okay, you determined what you want to analyze. I'm going to be analyzing fat content, or I'm going to be analyzing hydrolytic reactivity by determining total free fatty acid. Something. You determine what you want to analyze. Now you want to select the method. So how do you select the method? So you look at characteristics of the method. This is table 1.5 in your chapter 1. So you look at specificity, precision, and accuracy. Can you tell me the difference between precision and accuracy? You know, go back to your high school days and try to remember. What is a precise versus an accurate? Go ahead.
Statement has to do with reference.
Mhm.
How often do you take that result from accuracy? It's like how close to the target word.
Absolutely. So precision and accuracy are very important in making the decision in choice of the method. Sometimes the method is super complicated, has many steps, and the longer the method and the more steps in the method, the higher the chances of variability and experimental error. So your precision might go down. But also sometimes you use a method that is not going to give you an accurate result. So let's say you're looking for a protein content in a complex matrix, and instead of using Keldal as a method, you decided to use a spectrophotometric method like BCA. We'll talk about it later. You're not going to get accurate results. That was a poor choice of method for the analysis that you specificity. What does specificity mean? You know, definition of being specific. Yes, Rob.
So when in a test, being specific, it's like what you're doing is looking for exactly what you're looking for, and
Yeah.
not looking for taking into account everything.
Very good. We are going to do in the lab exercise total carbohydrate assay. Total carbohydrate assay is not going to distinguish if you have glucose or fructose or starch. But if you want to determine glucose, there is a specific assay, enzymatic assay, just for glucose, so specific for glucose. I wouldn't choose total carbohydrate assay to determine glucose. Applicability of the method. So if you have limited amount of sample and then an assay requires 100 grams and you only have 1 gram of sample, so that is not going to be applicable in your case. Do you have the equipment? Do you have the reagents? How expensive all of this is? Do you have the trained personnel, or you need to be trained? So is it useful in a sense? It might take 2 days to get the results, but you need really the results in an hour. So there are a lot of factors that goes into deciding what method to choose. Objective of the method. So are we wanting it for a nutrition label? Then we need to choose official method of analysis. So when you hear official, primary or definitive or a reference, all means the same thing. So there is a CFAT, Mojournier or Moginer is an official method of analysis for fat. But if you use NIR, it's not the official method for an analysis of fat content. So that we would call it a rapid quality control method or secondary method, like NIR or mid-IR. These are secondary methods, or moisture analyzer, infrared moisture analyzer. These are secondary methods of analysis. They're called secondary for a simple reason. They need calibration, and you use primary method to calibrate. So if you remember this for now, we're going to talk a lot about many different official versus rapid. online processing measurements. Also, when you just want to determine if your process is going well, you don't have hours to determine. You just have to take a sample and quickly run it through your IR equipment to determine, okay, moisture is fine, ash content is fine, we're moving on. Composition of the food. We are going to talk about it a lot. Depending on the composition of the food, you choose preparatory methods. So, for example, for fat analysis, this is a very common example I give. We use Soxhlet or Mojiner method. For Soxhlet, you need to have no more than 10% moisture. And when we cover that method, we'll talk about it. And if you have high carbohydrate, in order to determine the exact amount of fat, you really need to break that carbohydrate down. So the composition of the food determine how you prepare the sample and what method you would use. So here's an example. To extract and analyze fat content in a food product high in carbohydrate and protein, the sample preparation may include pre-drying, acid hydrolysis, solvent extraction. Any guesses? Anybody that done fat analysis? Hint, hint, in my lab. Speak now. Caleb, come on.
I know you can use solvent extraction.
Very good. Have you ever done module for anybody in the lab? Okay, so we use solvent extraction. Very good. Yeah, give me another. Acid hydrolysis and Mojiner, we do acid hydrolysis when you have high carbohydrate, high protein. If you have fat and the fat content is really low, not that high, it's going to be entangled in your carbohydrate and in your protein. It won't be extracted to add hexane or even methanol or ether. It won't come out very easily. So you want to break down, hydrolyze, get that fat out. Pre-drying, depending on the method, like I said, Soxhlet, we need to pre-dry if it's more than 10%, and that will be explained in that lecture. Otherwise, you don't, if you're doing module. So it really depends. So here the answer, I said, well, may include, so may, not must, so it will be all of them. Okay, here's an example from the book. Here is different types. Let's look at flour, all right? Flour has very low, let's say it's your wheat flour, very low fat content. If we hydrolyze, we get 1.73% fat. If we don't hydrolyze before we extract the fat for analysis, we get 1.2. That's 0.5% lower. 0.5 out of 1.7, it's almost 1/3 less. So it really messes up your results because flour is really high in carbohydrate. You won't be able to extract the fat without breaking down that carbohydrate. So that's just an example. All right, 1 minute. I have 1 minute. Don't go, don't leave. I'll stop here, but I'll just quickly tell you what you're doing next week and what you need to pay attention to. Please don't start leaving. Hold on. Stay with me. Okay, so I sent you an email today. You will get an email from me every Friday. So sometimes there are a lot in there, but it's all for you to succeed in the class. So please read it. And it's all pertaining to the labs. Since it is going to be a computer-based exercise, you all need to have access to the program. So I sent you this instruction sheet. Please make sure to bring your laptops next week and make sure you go through the instruction so that when you get to lab, you're able to access that result. Okay? If you have any questions about that, you can email us, me and anybody. I will direct you to the TAs to help you out. But please do read that email. It tells you exactly what you need to do for next week's lab. Please bring with you lab notebook. Please bring with you your lab manual. If you don't have it yet, let us know. We'll print out the lab exercise from the manual for you. You need a hard copy. Okay, so please read those Friday emails from me. Canvas is updated with what you need for lab next week. And I also put the lectures out under week 2 for next week. If you have any questions, always ask.
So with the, I think I remember something in the email about doing nutrition labels into our notebooks.
Yeah, so you don't have to do it before coming to the lab,
We
obviously,
do it in
because,
lab.
yes, because you need to create those nutrition labels. So in the lab notebook, you will have data section. So that happens after the lab is completed, you insert for data. So do look, when I say, look at slide number 4 for what goes in your lab notebook, please do look at that. The slide number 4 is in, under lab, what is it called?
It's like,
Lab intro under lab material
Yeah.
folder on Canvas. So you would go to slide number 4, you'll see how you want to prepare your lab note. If you get lost, email us, we'll make sure that we explain everything to you. So next week in lab, we will use this program to generate nutrition label, look at reverse engineering, create a nutrition label for a chocolate chip cookie, and everything else in there is to help you know what you need to do. Okay, thank you. Enjoy your weekend. And you have a question.
all the, every single, like the question for you. Say that again.
Be that quick.
Yeah.
Yeah. You need the lab manual. Yeah, and the lab manual, chocolate fun. Yeah. Thank you. Thank you, guys.
Oh, it's gonna